Now today we are going to start our unit number 4. But before going to the unit number 4, I want to tell you something that we are going to take two tests per chapter. Okay, that test may include MCQs and include descriptive questions also. So after this lecture now, from next lecture onwards, continuously we are going to take the test on the three chapters which I have taught you earlier. That is the first chapter introduction, then second chapter design of slab, and then chapter limit state of collapse. That is singly and doubly reinforced beams. Okay, so on these three chapters you have to give the test, two tests per chapter. So that test will be designed accordingly. MCQ test is also there, and after that maybe descriptive test is also there. So today is I think Friday, no? Correct, Friday. So our next lecture is on Monday. So you prepared for first and second chapter up to the Monday, because first chapter is very small chapter, so it won't require much more time for the preparation. Okay, but the second chapter is quite a big chapter. You have to go for you have to study the different types of slabs. Okay, four types of slabs are there. So up to the Monday, you can prepare for these chapters. If you start now today itself you can finish chapter number 1. Then in Saturday and Sunday you can finish chapter number 2. So on Monday, your test will be there. Okay, and these marks will be considered for your term work. Please remember these things. Okay, your attendance and mark will be considered for your what we can say term work. Okay, so now we will go to the chapter number 4. First, we will see on the PPT, and then we will discuss in details. Okay, we will solve the problem theory. We will see the theoretical part and formulas, and I will explain you the things on the PPT. You write down the important points and you tell me after the writing it is finished, or shall I dictate you if the theory is there? If the theory is there in the slide, are you going to write by your own, or shall I dictate you the theory? जर स्लाइड मध्ये थेरॉटिकल काय असेल तर ते मी तुम्हाला डिक्टेट करू दे, मग तुम्ही लिहिताय का तुम्ही स्वतःहून लिहून घेताय स्लाइड बघून, काय करणार आहात? सो अकॉर्डिंगली आय विल टेक द लेक्चर. गिव्ह द रिप्लाय. मी काय डिक्टेट करू दे का?
हो सर.
ओके. हा, यू आर टेकिंग टू मच टाइम फॉर गिव्हिंग द रिप्लाय. पटकन रिप्लाय द्यायचा. हा, नाउ आर यू एबल टू सी माय स्क्रीन?
Yes.
Yes, sir.
Okay, now. So this is your fourth unit, analysis and design of T and L beams. Mostly the question in the exam on this chapter is on singly reinforced T beam and singly reinforced L beam. They will ask you in the exam. Okay, they won't ask you the doubly reinforced beam for this T and L beam section, because the doubly reinforced design is very what we can say long. So in the examination, the question will be on the analysis of singly reinforced T and L beam section. Okay, so now what is T beam and what is L beam? That is the first question. Now I want to make you one thing very clear. There is no beam in this world which is having any other cross section than the rectangle. Okay, every beam is having rectangular cross section only. There is no such a cross section in I am talking about RCC beam. Don't imagine steel beams. Steel beams are having different various steel rolled sections are there, different cross sections are there. But in the case of RCC beams, I predominantly says that any beam, you take any beam, it is having a rectangular cross section. तुम्ही घरात बघा तुमच्या, तुम्ही कुठल्याही कमर्शियल कॉम्प्लेक्समध्ये जावा, कुठेही जावा तुम्ही. ओके, इफ यू ऑब्झर्व द बीम्स, दोज आर इन rectangular sections. If you observe the beam, then those are in rectangular sections. Then what is the concept of this T beam and L beam? We are talking about T beam and L beam. You might imagine that the cross section of the beam is T shape, or the cross section of the beam is L shape. It is not the case. The cross section is not of T shape and L shape. It is the T action and L action gets developed in the beam. Okay, beam is of a rectangular shape only. Please remember this. The shape of beam is rectangular, but this type of T action and L action is developed in the beam, so that the beam is called as T beam or L beam. Okay, so first of all, you write down the introduction. I will dictate you the introduction, and then I will explain you the introduction in detail. Okay, so write down first. In a RCC structures, in RCC structures, when when slabs and beams, when slabs and beams in RCC structures, when slabs and beams are casted together, are casted together, are casted together, the construction becomes monolithic. Then the construction becomes monolithic. Then the construction becomes monolithic. Okay, full stop. Now you write down this very carefully by understanding. Uh, some portion of slab, some portion of slab, some portion of slab above the beam, some portion of slab above the beam becomes becomes part of the beam, becomes part of the beam, which helps in which helps in resisting which helps in resisting the compression stresses, which helps in resisting the compression stresses, compression stresses. Okay, what they have said in these two lines. Okay, you imagine that construction is going on, and slab, there is a casting of slab as well as of beam, as well as we have to cast the beam. If this slab and beams are casted at the same time, okay, means first the concrete is poured in the beam, okay, and after that the concrete is poured in the slab. Both the beams and slabs are laid with the formwork, the required formwork, and the concrete is laid in the beam as well as it is in the slab. Then it is called as monolithic, which is casted at the same time. Okay, so when these two beams and slab are what we can say casted at the same time, then what will happen? The beam is below the slab. Okay, slab is above the beam, but due to this monolithic construction, some portion of the slab which is on the top of the beam, it acts like it is itself is a part of the beam, although the beam is rectangular, okay, and it is below the slab. But due to this monolithic construction, what will happen, sometimes the slab above the beam is act as a part of the beam. It is acting like as it is a part of the beam, it is not a slab. In that way it is acting, okay, and it helps that beam to resist the compression stresses. Okay, whatever the topmost part of the slab, it helps the beam to resist the compression stresses. Okay, so if I draw here a diagram, suppose now this is your beam, okay, and your slab is constructed above that, okay, so it may be the case this is like this, here may be the case it is like this, okay, so this is nothing but this is your slab, okay, and the remaining portion, this portion is your beam, this is beam. But what will happen due to the monolithic construction, now this slab is behaves as it is a part of this beam. Okay, this top slab behaves as it is a part of this beam. Okay, so these two slab and beams, there is T action generated in this slab because this slab is now it is acting as a flange. Okay, it is acting as a flange. Okay, and what is, and the rectangular section will act as a web. But remember this rectangular section will act in this way. Okay, so here this will act as a web, this whole section, and this remaining section will act as a flange. Okay, so you remember that beam will act as a web and slab is acting as a flange. Okay. So this type of action gets generated. So this is called as T action. Okay. And same action is there if the beam is the corner beam. Okay. If the beam is placed at the corner, then instead of T, L action will be generated because that beam is the slab is on, either it is on the left hand side or either it is on the right hand side of the beam. As it is a corner beam, it is the end point of the structure. Okay, so at that corner point, so where is the ending of the structure is there, at that point the slab may be there on the left hand side or maybe on the right hand side. Either side slab is not present, it may be present on left or right. Okay, so that is why the wave action will be there in the shape of in L shape. Okay, so these types of beams are called as what we can say, L beams. Okay, or L action gets generated. The principle is same. Okay, if the slab is continuous at both the sides, then T action will be there. If the beam is corner beam and slab is there on either side, then it is L beam. Okay, but remember one thing, the beam is in the shape of rectangle only, and the slab which is placed above the beam, due to the monolithic construction, this T action or L action is generated. Okay, this is the main point which I want to tell you. So that is what is given in these four lines. Then the next it says that the portion of the slab, then it next says that the portion of the slab of section is called as flange. That I have already told you, this is called as flange, and the portion below the slab is called as web. So this is web. Okay, so write down the portion of the slab section, the portion of the slab section, the portion of the slab section is called as flange, is called as flange, and the portion below the slab, and the portion below the slab is called as web, the portion below the slab is called as web. Okay, so I hope through this introduction, what is T action and what is L action, it is clear to you. Just remember these things. T beam and L beam, it doesn't mean that its cross section is T or L. Okay, in the case of RCC structures, I am talking about. Okay. When the slab and beam are casted monolithically, then this T action gets developed. And how that T action gets developed? Because some portion of the slab raises the compressive stresses coming on the beam. Okay, it helps the beam to resist some compression stresses. Okay, okay. So the voice is breaking because now the network issue is there. Okay, due to the network issue, it may be happening that internet connection is not in my hand. Still, I am trying to make it better, but let us bear for some time. Maybe the it may catches the range. Okay, so the portion and also check your connection also. If you are not in the full range, then also you will face the problem. Now, are you getting my voice? Is it audible?
Yes, sir.
Okay, is it clearly audible from the start or it is breaking? What is happening exactly? Anybody please tell me, it is clear from the beginning or it is breaking in between? Okay, break होतोय. It is breaking. So it
ब्रेक
may,
होतं.
it is the problem may be due to the network issue. Hmm? Okay. So whatever I have told you in this 15 minutes, have you understood this? Even though if the voice is breaking, what I am trying to tell you, have you understood this? Because this is very important. The entire chapter is based on this. Huh? So, okay, you
लास्ट
are,
5 मिनिटाचं काय
huh?
लास्ट 5 मिनिटाचं काय कळलं नाही सर
Okay, I will repeat once again. Okay, so I will repeat once again. Now my voice is audible. I will repeat it for you. Yes, no, please give me the reply fast. Now, why are you wasting the time in the reply? I don't know. Just switch on the mic. Yes, no, tell me. I will continue. No, if you don't give me the reply, how can I know what to do? Because this is online teaching. I am not physically seeing you. Hmm? You should reply me fast. Okay. So I will repeat you. Those who have not understood, I will repeat for you. Okay. So what I mean to say that in this whole discussion, that there is no section in RCC structures that is having the cross section like T beam or L beam. Like it is having T cross section or L cross section. That is the first thing you should understand. Okay. So then what is this concept of T beam and L beam? So that T beam and L beam is nothing but when the slab and beam are casted together. Okay, at the same time if they are casted, then the bonding between the concrete is very strong as they are casted at the same time. Okay, you may observe that if the beam is casted separately and if the slab is casted separately, then the initial setting time, final setting time of the concrete, it is different for beam and different for slab. Okay, and the bond between those two concrete are not much or not much strong or not as much strong as when the slab and beam are casted together, then the initial setting time, the final setting time of both the concretes are same. Okay, and so that there is a strong bond developed between the slab and beam. Are you getting my point? Due to this, what is happening? Some portion of the slab, okay, which is above the beam, some portion of the slab which is above the beam, it acts as the part of the beam, okay, and it raises the compression stresses which are coming on that beam. The reinforcement and whatever may be the portion of the slab which acts as the part of the beam, it raises the compression stresses which are coming on the beam. So this type of action is called as T action. ह्यालाच काय म्हणायचं, टी ऍक्शन म्हणायचं. जर ती बीम कॉर्नरला नसेल, मध्ये आधे कुठं जर असेल स्ट्रक्चर मध्ये, तर ह्याला काय म्हणायचं, अशा ऍक्शनला काय म्हणायचं, टी ऍक्शन. आणि अशा बीमला आपण टी बीम म्हणून डिझाईन करतो. These types of beams are called as T beams. आणि हीच जर सेम बीम सेंटरला किंवा मध्ये आधे कुठं नसून जर कॉर्नरला असेल किंवा जिथून पुढे बीमचा एंड होत आहे, जिथून पुढे स्ट्रक्चर एंड होत आहे, ओके, कॉर्नरला असेल, तर एका साईडचाच स्लॅब त्या बीमवरती रेस्ट होत असणार आहे. बरोबर आहे का? दुसऱ्या साईडचा स्लॅब नसणार आहे, कारण तिचं स्ट्रक्चर संपलंय. So that when this type of condition is there, then their L action is get developed. Okay, so that type of beam is called as a L beam. So this is T beam and L beam. This type of beam is called as L beam. Is it clear now? Now the portion which is above the slab, the portion which is, sorry, above the above portion of the beam is called as slab, and the portion below the slab is called as web. Okay, that is what I have told you here. Is it clear now? Are you getting something out of it? Yes, no? Are you getting something? Or still you are having a problem in T action, or yes or no?
Yes, sir.
Yes, sir.
Okay, so shall we move forward then? Okay, we will take the next point. Now conditions for Now the conditions for T and L beams. So what are the conditions in which situation this T action and L action gets developed? So that we need to see. Okay. So the first condition is the slab shall be casted integrally. Integrally means monolithically, means at the same time. Okay. Integrity should be maintained. Integrity means what? Unity. The parallel word I am telling you, unity, it is like same, it is like uniform, all the properties of the material is same. Okay, that is called as integrally or monolithically. So the slab shall be casted monolithically or integrally. Here what I was telling you, that this slab is shall be casted integrally, okay, or monolithically. That is the first thing. Second thing, if the construction is monolithic or uniform or integral, then uh, there is effective bond action between that slab and beam. Okay, the strongest bond gets generated between the slab and beam, and this is the first condition. And second, this is the most important condition, is that if if the main reinforcement of the slab is parallel to the beam, okay, if the main reinforcement of the slab is parallel to the beam. So if I draw a diagram over here, so now imagine that this is your slab. I am showing just a plan. I am not going into the detail. This is the slab. Now here in this slab, now you imagine that, suppose this is your shorter direction, this is your Lx, this is your longer direction, Ly. Okay, imagine that this slab is a one-way slab. Okay, for time being, imagine that this slab is a one-way slab. So in the one-way slab, we always provide main steel along the shorter direction and distribution steel along the longer direction. So if I show you the main steel, then main steel will be like this. Okay, main steel, this is the direction of main steel. Are you getting me? This is the direction of the main steel. So what he's saying now, if the main reinforcement of the slab, if the main reinforcement of the slab is parallel to the beam, okay, if the main reinforcement of the slab is parallel to the beam. So now parallel means what? Suppose now the beam is here somewhere, the beam is now here is the support will be there. Okay, I will draw the beam over here. He beam खाली असणार आहे बरं का याच्या. So here the beam is there. So this is the beam. The drawing is not very good, but it is sufficient for understanding. So this is beam. You see that this is your beam. This beam is below this edge. या एजच्या खाली beam असणार आहे ही. And this is nothing but the length of the beam, the longitudinal axis. Okay, now if you see, this is your main steel. Okay, this main steel is parallel to the beam. This is the condition. Main steel is parallel to the beam. And suppose now the same beam is there, and here, okay, here I will take the different color, and now the slab is continued like this here also. Okay, and now this is also your Lx, and this is also your Ly, and now the main steel of this slab, okay, the second slab, this is your slab number 1, this is your slab number 2. So the main steel of this slab will be, so again imagine that this is your one-way slab. Okay, so the steel will be in shorter direction. So this is the direction of the steel. This is the direction of your main steel. Okay, in this way your main steel will be there. Now if you see this, from the both the slab, the, okay, so quickly I will draw that diagram again so that you will understand. Here, this is one slab, suppose this is one slab, this is another slab, okay, this is another slab, and there is a beam. Okay, here somewhere the beam is there. I will show the beam by different color and with different thickness. So here the beam is there. Here it is, the beam is there. Okay, so now if you see, the this is your slab number 1. Okay, this is your slab number 2. This is the shorter direction of the slab. Okay, is parallel to the beam. I hope you understood this. What is the meaning of? Now I hope you understood this. The main reinforcement of the slab is parallel to the beam. Okay. Okay. आवाज ब्रेक होतोय. So I am also checking the network also, but I don't know what is the problem today. आज जास्त होतोय ना जरा आवाज ब्रेकिंग तुमचे रिप्लाय. I don't know what is the problem there. I'm, but this is the important point. If you won't understand, you tell me again. I will again try to explain it. Okay. So these are the things which I want to convey you. This is first the monolithic construction. I want to tell you that the slab shall be casted integrally monolithically with the beam so that it effectively bonded together. Uh, and then the next thing is the main reinforcement of the slab must be parallel to the beam. Okay, so now there are three types or three cases are there. Okay, there are three cases for this T beam or L beam. So our case number one is very simple. It is just like your what we can say singly reinforced section. In that formula, if you replace your B by BF, then you will get the formula for this T section. So now the first thing is that when the neutral axis lies within the flange. Okay. Now first of all, we understood. Are you getting my voice clearly? Is it audible? Now I have changed the network. Now are you getting me clearly?
ब्रेक होतोय.
Okay. Roll number 53 is saying yes. Break होतोय कोणाचं म्हणणं आहे? बर. Now whatever I can do I have done. I have changed my network from Idea to Airtel. Still if same problem is there, then you have to bear it now. What else I can do in this regard? Okay. So so now here if you see uh, if you see this diagram, this is the width of the section. Okay, this is the width of the section. So this width it is known as BF. So this is the width of the section BF. Okay, so width of the flange. This is your flange section. This section is nothing but your flange section. So this section is flange and this section is web. Okay. So now the width of the flange, it is given, the notation given for it is BF. The total depth of the flange, it is called as DF. Okay. Then this is the reinforcement provided in the beam, AST. This is the reinforcement provided in the beam, and from the top up to the center of the reinforcement, this is your effective depth D. So and the width. So this BW is the width of the section. Now the condition is neutral axis lies within the flange. So this neutral axis lies where within the flange. So here the neutral axis is drawn. Okay, this neutral axis is lies in the flange. So if you draw the neutral axis, now if you draw the stress distribution diagram for this, so that this distance is xu. The distance of neutral axis from the top is nothing but xu. So here xu is less than df. Neutral axis is within the flange means what? Xu is less than df. So here you can see with on the diagram also. So this total depth is df. This total depth from this point to this point. This total is df. ओके अँड एक्सयू म्हणजे कुठून कुठला असणार आहे तर हे एवढं म्हणजे एक्सयू आहे या अप टू द न्यूट्रल ऍक्सिस द पॉइंट अप टू द न्यूट्रल ऍक्सिस if you see the xu is the distance up to the neutral axis and df is the depth of the flange as your neutral axis. This is your neutral axis and a okay, this is your neutral axis. As your neutral axis is lies within the flange, as your neutral axis is lies within the flange, your xu is less than df. Xu is less than df. Now if you draw the diagram, the stress distribution diagram, this is the normal diagram. The stress at top, this is 0.446 fck. This is your stress at top. Okay, now if you draw the diagram over here, the tensile force will be at this level of AST TU, the compressive force will be here CU. Okay, it is all acting at 0.42 XU, you know that the lever arm is 0.42 XU. So if I evaluate TU, then what will be the value of TU? It is 0.87 Fy into AST. You already know this. Okay, force is nothing but stress into area. Stress is 0.87 Fy, area is area of the steel AST. What about this TU? So now if you evaluate for this TU now, okay, sorry, for Cu now. So what is Cu? It is 0.36 FCK is your stress. Okay, 0.36 FCK is your stress. And what will be the area now? What is the area now? If you see the neutral axis is here, the fibers above the neutral axis are in compression and the fibers below the neutral axis are in tension. So this is the area which I should consider above the neutral axis. This is the area. Okay, this area we should consider while compressive force is there. This area is in compression. So what is the area now? This is the stress into area. Area is this, width is BF. And what about this depth? Depth is XU. So it will be BF into XU. It is BF into XU. So CU is equal to 0.36 FCK BF into XU. So this is your formula for compressive force, and which is acting at a distance of 0.42 XU from the top. So what will be the Z now? ZU. So it is D minus 0.42 XU. It is D minus 0.42 XU. So I hope you understood this. In the rectangular section our width was same, so width was B. So in the rectangular section we always took here 0.36 FCK B into XU आपण घेत होतो. रेक्टँगलच्या केसमध्ये आपण B into XU घेत होतो कारण त्या बीमची विड्थ असायची B. आता जर इथं तुम्ही बघितलं तर दिस इज युअर न्यूट्रल ॲक्सिस and the area above the neutral axis is in compression, but here the area is quite large area is there, so I have hatched that area. If you see the area, so this area is nothing but this area. If I want to calculate this area, then this area is BF into XU. This area is nothing but BF into XU. So that area we have considered over here to calculate the compressive force. Okay. So I will clear all the drawings. Now here all the formulas are written which I have told you already. That is Cu, to calculate Cu 0.36 FCK BF into XU. Tu is nothing but 0.87 FY AST. Okay, so this is the normal thing which we are doing in singly and doubly info sections to check XU is greater or XU max is greater. This we will look at the time of what we can say solving the numericals. At that time we will see about this, but this is also very easy, you know already this. So the main point is that when you are talking about Cu, okay, so when you are talking about Cu, so the formula for compressive force is nothing but to calculate force, the basic formula is stress into area. Your stress is 0.36 FCK and your area is BF into XU. This is for Cu. Similarly for Tu your stress is 0.87 Fy. This is your stress into area is AST. Okay, into area is AST. So this is your Cu and Tu for singly reinforced section when Xu is less than Df. When Xu is less than Df, that is your neutral axis is passing through the flange. When your neutral axis is passing through the flange, we have to consider this case. Okay, so this is our first case what we have studied. Now in the at next lecture we will go for these two cases when neutral axis lies outside the flange. In that again two cases are there. Df is less than or equal to 0.43 XU or Df is greater than 0.43 XU. Okay, so these two cases we will see in the next lecture.